Right, good day, everyone. Welcome to the STEM Lockdown Digital School. This is a grade 11 Life Sciences. I am your presenter, Onkarabetse Setswe. You guys can get hold of me on Twitter at Onkarabetse_S. Right, so guys, as we can recall from Friday's lesson, we looked at the underlying health diseases or health issues in relation to the breathing system. Remember, guys, we looked at asthma, we looked at bronchitis, we looked at emphysema, and we also looked at lung cancer. All right, so just recap those things and revise them. Okay, and the following textbooks were used for this lesson. Except this one, guys. Did not use this particular one for this particular lesson, but in the previous lessons, we did use the Zoom In Oxford textbook, and I do recommend that you guys get these textbooks on Snaplify, right? We also use the ACID study guide and the Life Science Solution for All Macmillan textbook. Remember, you can get these textbooks on Snaplify, and they are all free, all right? Okay, so we had homework on Friday, right? Now I asked you guys to please complete this question 2.2. This is from a common paper, okay? And we are going to go through the answers. I do see quite a few new students. So guys, if you are new and you want previous slides, you can just drop me an email and I will just show my email address at the end of the lesson, all right? So we're going to start with question 2.2.1. Remember, guys, please do send through your answers in the group chat, or alternatively, you can raise your hand and then we can unmute your mic and you can give through the answer. So question 2.2 reads, study the diagrams below showing some parts of the human respiratory system, then answer the questions that follow. Okay. So here we have our diagrams. This is the diagram of the respiratory system. And then here we have a process which is shown, and here we also have a process which is shown. So question 2.2.1 states, identify parts A, B, and C. So guys, I'm going to need answers from you before I reveal the correct answer. So even if it is the first time you're joining, just do not hesitate to send through your answers. Okay. So identify parts A, B, and C. Part A is present here. Part B is just underneath, right? It is that particular tube there. And then part C right there. Okay, guys, send through your answers. Guys have about a minute. Part A, Part B, and Part C. Okay, Kai says part A is the larynx. Great. And part B? B from Prashani says it's the trachea. Okay, and then what is part C? It is the right lung. That is from Prashani. Okay, let us see the answers. Okay, so A is the larynx, and Kai, you got it correct. B is the trachea, Prashani, that is correct. And C is the bronchiole. So just note, if you can just zoom in, if you're using a phone, you can zoom in and just see where the indication of this line ends, okay? It's indicating the bronchiole and not necessarily the right lung in its entirety. So the bronchiole which is being indicated is in the right lung, that is correct, but we are talking about the organelle inside the lung, okay? Sorry about that. Guys, someone's video is on, just, all right, cool. Question 2.2.2. Which process in the above diagrams illustrates inhalation? Is it process 1 or process 2? Which process in the above diagrams illustrates inhalation? Is it process 1 or process 2? Guys have a minute. Okay, Prashani says it's process 1. Do we have? And Arabida said as process 2. Sorry guys for revealing the answer fast. I accidentally clicked on it. Okay, so guys, it is a process 1. And okay, so the follow-up question is there on question 2.2.3, which reads, give 2 reasons from the diagrams to support your answer in question 2.2. So just before that, okay, just in case you got the above question incorrect, let us look at the arrows. Okay, in process 1, we have arrows indicating the movement of our thoracic cavity. Okay, and the arrows are pointing outwards, meaning that the ribs would most likely move outwards. Okay, and then we have here an arrow pointing downwards. And remember, at this part there, it is the diaphragm. Okay, so it is pointing that the diaphragm would most likely go down or be flat. Okay, and then in process 2, the arrows which are present there are showing us that it is going in. So would have a contraction of the thoracic cavity. It would decrease in space or length. Okay, and then the diaphragm, we have an arrow as well there, which is indicating it going up. Okay, meaning that, guys, if you remember from the characteristics of inhalation and exhalation, we did say that during exhalation, our diaphragm most likely will be dome-shaped or arced. Okay, and that is why question 2.3.2 is process 1, which illustrates inhalation. Okay, I hope we are sorted. Okay, and then question 2.2.3, give 2 reasons from the diagram to support your answer. So I want to hear what you guys said, your 2 reasons to support your answer. You can just write 1 reason, and then maybe another student can also write another 1 reason. Okay, so guys, even if you are new in class, do not hesitate to write in your answers. Okay, don't be scared. You can raise your hand or type in the group chat. Okay, Prashani says that the diaphragm expands. Okay, during inhalation. Okay. Do we have any other answer? Okay, Asemahle says the way the diaphragm in process 1 moved up. Okay. Any other answer? So, okay, Asemahle, just something to note, ne? You are referring basically to the arrows. So remember that we said inhalation is process 1, ne? And the diaphragm is not moving up. Look at the arrow, it is moving down. Ne? Process 1 is here. It is moving down, not up. The one that is moving up is in process 2. Okay. Then where the length of the thoracic cavity is increased. Beautiful, right? Okay. Oh, you made a mistake. Okay, so basically what you wanted to say was the thoracic cavity or the rib cage, right? So if you guys remember from the previous lessons, we did say that during inhalation, our rib cage moves upwards and outwards. Okay, so now let us look at the reason that inhalation is process 1. So the ribs are lifted, okay? The chest cavity expands, okay? And I think Prashani spoke about expansion. If I'm not mistaken, you spoke about the diaphragm expanding. So Prashani, just to note, it is not the diaphragm which expands, it is the chest cavity or your thoracic cavity. The diaphragm contracts and flattens, okay? And then ribs move outwards and upwards. Thoracic cavity enlarges and volume in the lung increases. Okay. Hope we are all together. Okay, no problem, no problem. Okay, let us move on. Question 2.2.4. Give the letters and the names of the muscles shown in the diaphragm oh, sorry, in the diagram, I think I just said a muscle, that are involved during inhalation. Give the letters and the names of the muscles shown in the diagram. So we're looking at this particular diagram now, okay, that are involved during inhalation. So you guys can just give me the letters, okay? But if you can, just write down the letter and the name of the muscle. So remember, guys, we are looking at this diagram here, okay? Question 2.2.4, we're looking at this diagram. Okay, Kai says E. It's the diaphragm. Beautiful. Our question is 4 marks. So we might actually need 2 answers to this. B, the bronchioles. Okay, remember the question said the muscles, okay, not organelles, muscles. The other muscle that is working during inhalation and exhalation. It is somewhere there by the ribs, just to give you guys a hint. The muscle is there by the ribs, just between the ribs. What is the muscle called? It's not the lungs. It is D. And what is the muscle called? All right, yeah, well, beautiful. So it is your external intercostal muscles, your intercostal muscles, guys. So the muscles that are involved, just to, guys, do not be confused between organs and organelles, right, and muscles, okay? So the muscles that are involved during inhalation and exhalation are your intercostal muscles and your diaphragm, right? Cool. And then question 2.2.5. It says, draw and label a diagram showing gaseous exchange across an alveolus. Use arrows to show the direction of gas movement. Okay, so guys, we'll just compare the diagram that I will just show on screen with the one that you drew, right, in your books, etc. Then can do that. Let me just see. Okay, so that is just our answer, which is D, the intercostal muscles, and E, the diaphragm. Okay. Wow, I already gave you guys the answer for question 2.7. Okay, oh well. Here is the picture, guys, that you guys are supposed to draw. So the marks are allocated as follows. You get 1 mark for the correct diagram. You get 1 mark for indicating how oxygen is diffused into the blood. Get another mark to indicate the carbon dioxide, which is diffused out of the blood, right? And your other 2 marks will go for the labeling of the diagram. So this question was 5 marks, okay? Is everyone okay with this? And then question 2.2.6, whose answers have already appeared, read as followed. When one makes use of a heater to warm a room, one is advised to place a small bowl of water next to the heater. Explain the purpose of this practice. Okay, so in the answer to question 2.2.7, okay, guys, just wait that. We're moving on, question 2.2.6. Okay, I'm sorry, guys. That is a question for the next Oh, yeah. Sorry, guys. My bad. My mistake now. So question 2.2.5, it is here now. And then question 2.2.6, it reads as follows. When one makes use of the heater to warm a room, one is advised to place a small bowl of water next to the heater. Explain the purpose of this practice. So you guys can send through your answers for question 2.2.6. The answers that had appeared as for question 2.2.7. All right. On the previous slide, do you want the questions or the answers? I'll just, okay, let me just go there. Here you go. All right. There you go. So I was asked to just go back to the previous slide quickly, but you guys can so long send through your answers for question 2.2.6. When one makes use of a heater to warm a room, one is advised to place a small bowl of water next to the heater. Explain the purpose of this practice. So guys, question 2.2.6 is basically referring to the bar heaters, right? Not necessarily your gas heaters, but the bar heaters. Okay. All right, no problem. Please send through your answers for question 2.2.6. I'll give you guys a minute before I reveal the answers. Send through your answers, guys. Answers, why would we place a bowl of water in front of a bar heater? What would be the reason for that? Placing a bowl of water in front of your heater. And guys, is it the first time you hear about this practice? Because I'm not seeing any answers. So I don't know, is it the first time that you guys hear about this? All right, no problem, no problem. So guys, as I have said, now this is usually for bar heaters, and nowadays we actually have those fan heaters that we don't usually put water in front of them, and we also have these gas heaters. Okay, so Asamahle says so that the heat of the air will cool the water. Right. Okay, that is basically close enough. But let's see the correct answer. It says it increases the amount of moisture in the air because water evaporates. And I guess that's what you meant by saying that the heat of the air will cool the water, I guess, or the other way around. But anyway, it is because water evaporates, right? And it prevents drying out of the inner surface of the lung, which would prevent gaseous exchange, okay? So again, remember guys, when we looked at the composition of inspired air versus the composition of expired air, usually the air that we breathe in, it has water vapor, right? A certain percentage of water vapor. So when we put that water in front of our bar heater, it will basically make the air that we breathe in less warm, all right? It would put it to a verified temperature, and it would also contain the water vapor, okay? And it will prevent the inner surface of our lung from drying out, okay? So we would be prevented basically from breathing in hot, dry air, okay? But as I have said that I don't think most of us use these bar heaters anymore. So it is usually not applicable now. Right, so it's used to humidify the air. Yes, that is correct, Kai. It is used to humidify the air. Yes. Okay, and then question 2.2.7, whose answer has already been released. It says a person's thoracic wall is punctured during a motor vehicle accident. Explain how this injury will affect the breathing process. Okay, so if a person's thoracic wall is punctured during a motor vehicle accident, how is basically the breathing process affected? Firstly, the person won't be able to breathe, the lungs will collapse, and then we'll have no pressure difference between the exterior, which is our atmospheric pressure, right, and your thoracic cavity. So basically, there would be no difference between your atmospheric pressure and the pressure in your thoracic cavity, and hence we won't be able to breathe. Okay, so that would be because of a puncture in the thoracic wall. Okay, thoracic wall being your ribs and further into your lungs, right? So remember, guys, if you do have any questions, do post them in the group chat or alternatively raise your hand. Okay, let us move on. Okay, beautiful. So guys, today we're looking at smoking and our health, right? Firstly, we know that many people, guys, they find it difficult to stop smoking cigarettes once they have started smoking. That is because it is very addictive and it quickly becomes a habit. So that is why we are discouraged from starting to smoke, especially at a young age, okay? So guys, here we can already see it, the lungs of a non-smoker versus the lungs of a smoker. So that is why, guys, you are advised not to smoke because you don't want your healthy lungs to turn like this. This is going to make gaseous exchange, breathing very, very difficult. Okay. So this is how the lungs of a smoker looks like. And guys, it doesn't take a lot of time for your lungs to actually move from being like this to this. Okay. Remember, it is also a process. You know, every day you take a smoke, you take a puff, it builds up, and it builds up, right? So let us look at the harmful effects of smoking. Okay, smoking is dangerous and it can lead to death. Okay, about 6 million people worldwide die from long-term effects of smoking tobacco-based products. So again, guys, let me mention this. When we're talking about smoking, we'll be focusing mainly on cigarettes, okay? Mainly on cigarettes. Okay, and then smoke from cigarettes contains over 4,000 substances that are harmful and poisonous. And some of these substances are nicotine, tar, and carbon monoxide. And we will look at these substances into detail. Right, so nicotine, guys, this is a poisonous drug, right, which is very, very dangerous in large doses. And it doesn't immediately kill you, okay, but it can cause serious health problems. And this is basically the substance which makes cigarettes very addictive. Okay. Let us look at nicotine. So tobacco leaves contain nicotine. When a person smokes a tobacco product, the nicotine is inhaled and passes from the lungs into the blood. From the blood, it travels to the brain and produces a feeling of, okay, sorry guys, it's a feeling of pleasure, okay? Was supposed to be a feeling of pleasure, and it also causes arteries to narrow, causes an increase in the heart rate and blood pressure, and an increased risk of a heart attack. Okay. So just note these characteristics of nicotine. Remember, it is very addictive. So it is also the substance which would cause withdrawal symptoms in people who would like to stop smoking. And those withdrawal symptoms include headaches, you know, irritability, inability to fall asleep, and the difficulty with concentrating. Right. So here we have basically the effects and how nicotine travels in the body. If you guys can just follow with me. Number one, it is right here. It is the mucosal linings of the nose and the mouth. So nicotine is absorbed through the mucosal linings in the nose and mouth. Any nicotine products, being your cigarettes, e-cigarettes, chewing tobacco, lozenges, and dissolvable tobacco. Okay, and then number two is by your lungs. Inhaled nicotine passes through the lungs into the bloodstream, right? And then thirdly, that is by your heart. It makes its way to your heart and is transferred to the arteries and the brain. So remember, all the gases which are exchanged at the lungs, they all travel via your pulmonary vein to your heart, and from your heart, it is pumped out to your body cells. Okay. Then number four, that is in your brain. So in 10 to 20 seconds, the nicotine reaches the brain to stimulate the release of neurotransmitters, adrenaline, and dopamine. And that is where we derive the pleasure from, okay? And that is also what we are addicted to, this pleasure of the release of adrenaline and dopamine. Okay, and then number five is by your liver and your kidneys. Nicotine is metabolized by the liver and filtered by the kidneys to be excreted in urine. Okay, so this picture basically comes from the Cancer Council SA's website. Right. Okay, let me see if we have any questions. Cool. Okay, guys, tar, right? So now tar, remember, it's another harmful substance that is found in your cigarettes. So it is a sticky carcinogenic substance, and it is usually derived from coal, né? And it causes the yellow brownish stains that are found on teeth and the fingers of smokers. Okay. So as we have mentioned, that it is a carcinogenic substance, causes yellow brownish stains, and it is absorbed by the lining of cells on the bronchi and bronchioles. All right, now let us see what tar causes. Firstly, tar is the reason for lung cancer, as well as many other cancers. Secondly, it damages the ciliary lining in the air passage. Okay, guys, just quick question. What is the function or the role of ciliary lining in the air passage? What is the function of ciliary lining in the air passage? Just before we continue. Send your answers to the group chat, guys. The function of the ciliary lining in your air passages. The function of the ciliary lining in the air passages, because as you can see here, the tar, it damages the ciliary lining. So what would happen? Okay, so we have an answer that says to trap dust. Okay, does anyone have any other answer? Okay, just 10 more seconds. All right, so Rarabilo says it is to trap dust, and that is correct, because remember we have mucus, right, on our ciliary lining, and that mucus basically traps dust and traps all other unwanted particles. So the ciliary lining basically moves up the mucus with the dust particles, right? It moves it up out of our respiratory system. Okay, so if that is damaged, then that means that the dust will just go through and damage our respiratory system, right? Third reason, extra mucus is to be made by the goblet cells, right? And that is a cause of turner, guys. And then number four, it damages the alveoli. What is the disease, right, in which we have a damage of the alveoli? The disease that we dealt with last week, where the alveoli is damaged. The disease that we dealt with where the alveoli is damaged. There was a disease that we looked at, and we said that it is characterized by damage that happens to the alveoli. What is the name of that disease? Please do use the group chat to send through your answer. Damage of the alveoli. Okay, I have Asamat and Prashani who say TB. Okay. Do you have any other answer? Okay, Asamatla also says it is, sorry, lung cancer, all right? Damage of the alveoli. All right, cool. So remember, guys, TB, we said it is caused by the bacteria, which is Mycobacteria tuberculosis, right? And it affects the lungs, okay? And we did not specify as to which part of the lung it affects, okay? And we also mentioned symptoms there is coughing out blood, being fatigued as well, right? And then the disease where we have damage of the alveoli, which is highly characterized as damage of the alveoli, is emphysema. Right, remember I showed you guys a picture of alveoli in a healthy human being and alveoli in a person who has emphysema. And we also mentioned that in emphysema, gaseous exchange does not take place properly because we have less alveoli which are present. So as for lung cancer, that is also correct. Alveoli can be damaged during lung cancer if the tumor also occupies your alveoli. But the main disease in which it is characterized by damage of the alveoli, it is emphysema. Okay, guys, just go back to your notes. It is emphysema, right? Okay, and then tar also causes inflammation of the linings of air passages. Okay. And guys, another disease that is caused by inflammation of linings of air passages, what is that? We dealt with it on Friday. A disease which is characterized by inflammation of linings of air passages. You can send through your answers to the group chat, guys. Beautiful. Yes, it is a bronchitis. Thank you, Arabile. Okay, then let us look at carbon monoxide. So basically, carbon monoxide is a gas, it's colorless and very much poisonous. And people who smoke don't usually even know that it is present in smoke. Okay, so carbon monoxide is absorbed from the lungs, okay, and then it gets into the blood and it combines to hemoglobin. All right, so let's do a quick revision. Hemoglobin, what's the function of hemoglobin? The function of hemoglobin. You can send through your answers to the group chat. Just short answers, guys. The function of hemoglobin. What is the role of hemoglobin or the function of hemoglobin besides it giving blood its red color? Okay, besides it giving blood its red color. So the function of hemoglobin in relation to gaseous exchange. Okay, as Samantha says, it carries oxygen to the lungs. Prashani transport gases to its cells. Perfect. Beautiful, guys. Thank you very much. So hemoglobin, remember we did say that oxygen, which is diffused in, binds to hemoglobin and is transported to the body cells, through the body cells in hemoglobin, right? And carbon dioxide, and rather that compound where we have oxygen binding to hemoglobin, we call it oxyhemoglobin, right? And then carbon dioxide also has a tendency of attaching to the hemoglobin in order for it to be diffused out, and we call that carbohemoglobin, right? Carb hemoglobin, right? And then there is less hemoglobin that will be available to carry oxygen needed in respiration if we inhale carbon monoxide because of the reasons that you guys gave me, right? And then we have an increase in breathing and heart rate to compensate for shortage of oxygen. Okay, and then women who smoke during pregnancy reduce the amount of oxygen that is available for the fetus. Also because of the reason that we said that we have less hemoglobin that would carry oxygen needed for respiration. All right, let us move on. So guys, this pie graph is basically showing the proportion of deaths from smoking for different related diseases. So let's say that smoking causes cancer, chronic bronchitis and emphysema, causes other diseases including stroke and heart disease. Okay. Right, now let us look at secondhand smoking. So guys, non-smokers are affected by the smoke that comes from cigarettes because they breathe in the secondhand smoke and it causes passive smoking, all right? So passive smoking is basically breathing in tobacco smoke from people's cigarettes, okay? And it causes smoke-related diseases similar to those of a smoker. And then children would become more prone to respiratory diseases such as asthma and bronchitis when they take in the secondhand smoking. So guys, because of secondhand smoking, a ban was placed on smoking in public places, and it is passed to protect non-smokers and especially children. So we're just going to look at some of the laws. So smoking legislation in South Africa with regards to smoking. So the laws that were introduced to deter people from smoking, as I said, guys, you are discouraged from smoking. Even in this lockdown, smoking is very much discouraged. It is also to protect non-smokers from exposure to secondhand smoke, and it is to encourage smokers to give up smoking. And I guess the reason why it is prohibited now as well, it is also to intensify the encouragement of smokers to give up their smoking. Okay. Now here are some of the anti-smoking laws. Banning advertising tobacco products, right? They have banned sponsorship by tobacco companies for sports and arts. Tobacco products they should contain health warnings, and then a ban on selling tobacco products to people under the age of 18 was introduced. Then no smoking in the workplace, no smoking in a car with a child under the age of 12, and no smoking in public places. Right, so these are some of the anti-smoking laws that were placed. Right, then we look at artificial respiration. So guys, artificial respiration is basically a method to start and maintain breathing once it has stopped. Okay, it's a method we use to start and maintain breathing once it has stopped. So let's go through the notes. Sometimes people are involved in accidents, for example, drowning, and they may stop breathing. And this results in their brain cells not receiving oxygen because of the damage. Okay. Then this can be prevented if the patient has an emergency procedure called artificial respiration. Remember we said that artificial respiration is a method to start and to maintain breathing once it has stopped. Okay, a method to start and maintain breathing once it has stopped. Right, so it restores or maintains breathing in people who can't breathe on their own, and it should be carried out as soon as possible after the patient has stopped breathing. The most common method of artificial respiration is mouth-to-mouth resuscitation. Okay, and I'll show you guys a picture of that. So here we have mouth-to-mouth resuscitation taking place, and I'm just going to go through the steps with you guys. So step one is you place the unconscious person on their back. This is a person who can't breathe, guys. You place them on their back. You place one hand on the person's forehead and you pinch the nostrils shut. so that once you blow in the air through their mouth, it doesn't come out through their nostrils, okay? You tilt their head backwards, that is to open the air passage, which is our trachea, and then place fingertips of the other hand under the person's chin and lift their chin up to open their mouth, okay, just as indicated in the picture here. Then step 2, take a deep breath. Open your mouth and place your lips on the person's mouth to make an airtight seal. So you're breathing in, and then you're gonna breathe out into the person who has stopped breathing. So a question might arise for it, like that, if we breathe out, because we breathe out carbon dioxide, how will that be helpful? So guys, this is where we need to revert back to the lesson where we looked at composition of inhaled air and the composition of exhaled air. Remember, in inhaled air, we have a high concentration of oxygen, and in exhaled air, we still, in as much as we have a lot of carbon dioxide, we still have oxygen, which is expired. Okay, so that is why mouth-to-mouth resuscitation is also advised. Okay, is everyone following, guys? Is everyone following? Are we all together? Can you use the yes and no button on participants? If I do need to go slower, just indicate for me. All right, cool. Okay, beautiful. All right, now let us go back to step 2. We're taking in a deep breath, right? And then you open your mouth, place your lips on the person's mouth to make an airtight seal. Breathe out into the person's mouth, but gently. And then if the person's chest rises, sufficient air is getting into the lungs. And if the chest does not rise, reposition the person's head or check for an obstacle that might be blocking the air passage, okay? Then step 3, you lift your mouth off the person's mouth and you listen for exhaled air coming from the person's lungs. Then you need to repeat step 2 and 3 at a steady rate of 1 breath every 5 seconds. And you continue mouth-to-mouth resuscitation until the person can breathe on their own. So guys, mouth-to-mouth resuscitation also forms part of CPR. Right, and CPR, that is where you basically compress the person's chest, okay, and it's usually used in people who drowned or something like that when they have obstruction, in order to push out the obstruction that might be present in their air passages. Okay. Okay, so guys, I remember I asked you guys to do a practical activity on using a spirometer or creating a spirometer. And I wanted to actually do the practical and show you guys a video about it, but I did not have tubes to basically, this tube here that is being used, I did not have that, so I couldn't actually do the practical. But I just wanted to go through this with you guys, the significance of this practical. Okay, like I said, it is on page 221 in the Solutions for All Macmillan textbook that you guys can get on Snaplify. It's free, right? So in this practical, guys, we were supposed to make a spirometer, right? An incentive spirometer, and it was supposed to look something like this. So guys, spirometry, basically, it measures how well your lungs work by measuring how much air you can inhale and how much air you can exhale. So you were gonna be able to measure that once we have done this practical. Okay, so that is why I wanted you guys to look at that, because we'd be dealing with lung capacity, okay? So just for enrichment purposes, let us look at the next slide. So some spirometers, they are very well advanced, and they can give you guys a graph which will indicate your inspiratory reserve volume. And okay, and what this basically means is, okay, let me just start here, guys. Let me start here at these part here. You see these waves here, which are between these blue lines. This is called your tidal volume, okay? And that is when you're doing quiet breathing, okay? And then inspiratory reserve volume is when you forcefully inhale, right? Like if I say 1, 2, 3, inhale air, and you can basically see the movement of your rib cages. That is the volume of the lung, né? of how much gas you can inhale. It's just showing the amount of the reserve inspiratory volume your lung has, okay? And it is not used, during quiet breathing. And then expiratory reserve volume, it's indicating how much air you can exhale. All right, and it is indicated there. Okay, so advanced spirometers can give you an indication of your inspiratory reserve volume and your expiratory reserve volume, as well as your tidal volume. So guys, remember, this is just for enrichment purposes. Okay. Then we are done with respiration and gaseous exchange. Guys, here is homework. Please do take screenshots and then we'll mark tomorrow. Please take screenshots or write it down. So we have a long question here and we have questions here. So we're just wrapping up gaseous exchange. Guys, another thing, because time is really not on our side, just take screenshots. One last thing, if you guys want to do a revision on gaseous exchange, I need you guys to email me or just quickly send it in the group chat. Okay, if you want us to do a revision, basically summarize gaseous exchange, then just do indicate for me, or if we can move on to the next topic, which is excretion, then you can also just indicate for me, all right? So please do take pictures, screenshots of the homework, and then we'll mark tomorrow. Okay, so I have Prashant who says we should move on. And guys, if you need any slides from the previous lessons, do indicate to me. Right, I hope everyone is done with that. Okay, someone says we should do revision. So guys, I need us to vote this out. Revision, or are we moving on? Are we doing revision or moving on? And guys, here is my email address. If you want slides, do send me an email. And then please remember to follow Africa Teen Geeks on all their social media platforms, right? And tell your friends about it. We have life science at 1 o'clock. Okay. Prashani, you can't vote twice though. Guys, quickly, are we doing revision or are we moving on? Anyone else besides Kai and Prashani? Please respond. You'll be the tiebreaker. Quickly, please. Yeah, okay. Seems like we'll move on and do revision. Yeah, I guess we'll do revision when we're doing the questions now. Okay, guys, thank you very much. Enjoy your day further.